In this new video, we will see definition of double integral in polar coordinate and formulation of double integration in polar coordinate. Definition of double integral in polar coordinate is as follows. Suppose A is a region which is bounded and f of r comma theta is a function in polar coordinate. Then we divide the region A into n equal parts of areas delta A1, delta A2, delta An. And if rk comma theta k, this is a point inside the rth elementary area delta Ar, then we define the double integral as which is on your screen. You can watch the double integration of f of r comma theta into dA equal to limit n tends to infinity delta Ar tends to 0 summation of f of rk comma theta k into delta Ar delta Ak, where this k is varies from 1 to n. This is an definition of double integral. Now friend, we take the evaluation of an double integral in polar coordinates. Let A be a region bounded by r equal to theta, f1 of theta, r equal to f2 of theta, theta equal to alpha, theta equal to beta. Then the double integration f of r comma theta into dA equal to integration alpha to beta, integration f1 of theta to integration of f1 of theta to f2 of theta, f of r comma theta, r into dr into d theta. Integration in the bracket is evaluated first taking theta as a constant. Now to do this, let us suppose we divide the region A into small elementary areas of delta Ar. Let me draw the first. Suppose this is my region and this is a fixed line. This is fixed line O and X. From this fixed line we can measure angles, and suppose this is and radii r1, this is a radii r2, and this is and these are the angles. So we take these are the angles and radii. We divide this area into equal parts like this. This is by taking the radii, and this is an radii making an angles, different angles. So let us take this is the region. Suppose let it call as m n m n p and q, and suppose this is a radii d e f and g. This makes an angle. Suppose this makes an angle theta, and another angle is theta plus delta theta. Okay, and this radii, that is, let us calculate the area m n p q. We have divided this area, total area, into small elementary areas by drawing the radii and different angles, by taking different angles. Then the radii d m n and e, this is an radii of distance, suppose r, and another one is f, q, p and g, whose radii is r plus delta r, and this is at angle theta, and at angle theta plus delta theta. The area of MNPQ, this MNPQ equal to area of sector this OPQ minus area of sector ON and M, and we know that area of sector is 1 by 2 into radius square 1 r plus delta r whole square into del theta, and ONM 1 by 2 r square into delta theta, okay. So 1 by 2 common, r plus delta r whole square, r square twice r delta r plus delta r square, and this is delta theta, okay, minus 1 by 2 r square and delta theta. Here you can see that the first term 1 by 2 r square, 1 by 2 r square delta theta will be cancelled, and we have with this r into delta r, and this is an delta r square d theta square. So eliminate smaller part, if we eliminate the smaller part, this one delta r square into delta theta and delta r both are small, and therefore we eliminate that part, and we get the area MNPQ is r into delta r. Now you can see that we can measure all the areas in this strip from R1 to R2, and then take summation over all these circular strips, so that the term is divided into, this total sum is divided into two parts, that is double integration over a f of r comma theta into dA, this is equal to, in the limiting case n tends to infinity, delta ar delta theta tends to 0, summation for r1 to r2 into summation from theta to, here we take theta here. What is theta? Theta is, suppose this angle is alpha and his whole angle is beta, these are the boundaries. So theta equal to alpha to beta, and summation from r1 to r2 f of rk theta k r into delta ar into delta theta. But the region is bounded by r1 equal to f1 of theta and r2 equal to f2 of theta, therefore this limit delta ar tends to 0, summation r1 to r2 f of rk theta k r into delta ar, this will be integration f1 of theta k to f2 of theta k, f1 of theta k to f2 of theta k, f of here f of r k, f of r theta k into r into delta r, here r into dr, okay. But this is a total function of theta. Now it is converted into function of theta, you can see this is converted as a function of theta. When we evaluate this with respect to r and substitute upper limit and lower limit, which are values of theta, so it is a, finally we get a function of theta, and let us call it as a f of theta c, okay. Then this is double integration over a f of r comma theta into dA equal to limit n tends to infinity delta theta tends to 0, and this is summation alpha to beta f of theta into delta theta. This is nothing but an integration alpha to beta f of theta into d theta. Substituting the value of f of theta alpha to beta, if we substitute here f1 of theta to f2 of theta, f of r comma theta into r dr into d theta. So this is an double integration which is converted over the region A is converted into a bounded region.